in today's class, we're basically going to take all the transformations we've been learning throughout the week and put them together. And my hope is because we sort of split it up and did them one at a time, today's class will be pretty straightforward because you're sort of used to all the transformations. So before we start, let's talk about all of the transformations together. We have talked about A. Does anyone remember what the letter A stands for? Yep, Sarah? Exactly. So the letter A stands for either a vertical stretch or a vertical compression. If it's a whole number, it's going to be a stretch. If it is a fraction, it's going to be a compression. And then you have the positive C, which tells you it is a vertical translation. If the number is positive, you go up. If the number is negative, you go down. The thing to remember here is anything outside of the bracket is considered to be a vertical transformation, and it is going to affect the Y value in your mapping coordinate. Then we have the stuff inside of the bracket. And the most important thing to remember for this, which we're going to practice a lot today, is you have to remember to factor it so that it looks exactly like that. Like you want a number and then brackets X plus or minus something. So we're going to have lots of examples where it's not going to be factored. We will always remember to factor it first. We're going to sometimes get a K value. The K value is a horizontal stretch or compression. So horizontal stretch and horizontal compression, we take the opposite. And then the letter D is going to be a horizontal translation, and we take the opposite. The key thing to remember here is anything inside of the bracket is a horizontal transformation, and it affects the X value in your mapping coordinates. Okay, so all of the summary, all of this stuff is laid out for you guys in the chart. I won't spend too much time on it because I want to get right into the questions, but just take a look. Vertical translation is a number here, and you add it to your Y value. A horizontal translation is a number inside of the bracket, and you add it or subtract it to your X value, always the opposite. Another key thing to remember is a vertical and horizontal translation. These are the only things that affect your asymptotes. So we can just make a little point right here that if you are drawing asymptotes, just look out for a horizontal and vertical translation and be mindful of that. Then, oh, we forgot reflections. If you have a negative sign on the outside, that is a vertical reflection in the x-axis. It's going to be added onto your y or multiplied to your y. And if you have a negative sign inside, that is a horizontal reflection in the y-axis, and that's going to be multiplied to your x. A vertical stretch or compression, again, affects your y, and a horizontal stretch or compression affects your x, and it's the opposite. So you multiply by the reciprocal. So here are all of the transformations. I never tell you to memorize this because I think it's actually much easier just to use common sense when you're doing these transformations. And I'll show you what I mean by that. Okay, so just for you guys online, I'm going to zoom out. So if you want to see the big picture, that's what it looks like. Let's get into graphing. So I have 6 examples here, and for each of them, what we're going to do is some of them are the graphs we've been learning, like the absolute value graph, the square root, and the rational, and others are just these random functions like the one I have here. The first thing we're going to do, don't look at the answer, I kind of gave it away, but we're going to list all of the transformations. And when I'm listing the transformations, what I do is I just start on the left-hand side of my function, and I just go in order listing all of them as they appear. So here we're using the letter F because the squiggly line that we have, it doesn't have an actual formula. It's not a square root function. It's not an absolute value function. It's just some random function that we don't know how to make an equation for. So we're going to call it f of x, and we're going to use the letter F. Sarah? Yes, always, yeah. So for this function, we have the letter number 2, and that number 2 is going to give us a vertical stretch by a factor of 2. And then we have a -5 inside of the bracket, and that's going to tell us that there is a horizontal translation 5 units to the right. Now, it is going to be very repetitive to keep doing the transformations all the time. If you want, just for your notes, you could use a couple of short forms like VS for vertical stretch, HT for horizontal translation. And I think probably by the 4th example, I'm going to start doing that as well. So I'll give you a second to write that down. All right, so when I'm given a random graph like this, the squiggly line graph, what I'm going to do is I'm going to identify a couple of key points. And I'm going to write those key points. And by the way, this graph, I'm going to just label y is equal to f of x. And I always list those points on the left-hand side of my table of values. So over here, this is x comma y. And we have -6 comma -2, -3 comma 3, -1 comma 0, and 2 comma 2. If you guys are angered by the fact that the numbers are not on the actual line, I'm with you on that one. I find it so annoying that the numbers are sort of like floating around. What is with this? Super annoying. Okay, so that's your y is equal to f of x. Now what we're going to do is we're going to take all of the transformations here and put them in our mapping coordinates. What is the only thing that affects your x value in this question? Bea? Yeah, and remember, if it's inside the bracket, we actually have to look at the opposite. So if it's -5 in the equation, what are we going to put in the mapping coordinates? Good, so this is going to be x plus 5. Okay, and what is the only thing that affects the y value here, Sarah? The vertical stretch, which is just 2. And what do we do with vertical stretches? We multiply them to our y. So it's going to be 2y. And so this is kind of what I was alluding to the whole time this week, where I'm like, don't just randomly move the points, because eventually we're going to get questions like this where we have multiple transformations. So if we use our mapping coordinates, it makes the question so much easier. I would say that's the hardest part. Now, all we need to do is take all of our x values, add 5 to it, take all of our y values multiplied by 2, graph that, and that's it. We're done. The transformations should be represented in the graph. So -6 plus 5 is going to be -1. -3 plus 5 is 2. -1 plus 5 is 4. And 5 plus 2 is 7. -2 times 2 is -4, 6, 0, and 4. Two comma 6, 4 comma 0, and 7 comma 4. Make sure you guys are using a ruler when you do this. And make sure you label your graph with the equation that the question is giving. Okay, so, and also once I'm done graphing, I do try to see if it makes sense. So does it look like our graph has moved 5 units to the right? Yeah. And does it look like it's sort of stretched out like this? Yeah, it does. So we're probably on the right track. And now we're also going to practice our domain and range for these questions. So we're going to do the domain and range just for the transform function, not the original one. So my graph starts at -1 and it ends at the number 7, it seems, which means my domain is going to be the set of all x values such that -1 is here and 7 is here, and x includes all real values. And for the range, it starts at -4 and ends at 6. So the set of all y values such that y is going to be between -4, I said, and 6. And y includes all real values. Does that make sense? That's basically what we're going to be doing now. Just we're going to add that little factoring bit, and that's it. Let's go on to question number 2. So question number 2 is y is equal to a half f of bracket -x plus 4 bracket -2. Why am I using the letter f? Because this isn't one of the functions we know. It's not an absolute value function. It's not square root. It's not a line. It's not a parabola. It's just a random function. Actually, it's the same one as before. So we have to use function notation for that. Now, do you guys notice that inside of the bracket, we don't have a function where the x is with a number by itself. See how the x has a negative in front of it? We never want the x to have anything with it. If you do find a situation like that, you have to remember to factor out the negative. So when you do that, what it's going to look like is it's y is equal to a half f of, I factor out the negative, and I'm left with just x minus 4 minus 2. Okay, and now you can see that our k value is actually, sorry, not a k value. We have a horizontal reflection and we have a horizontal translation. That's the most important thing really for this lesson, and the rest of the questions all require factoring, so we're going to do it a bunch of different times. Okay, what are the transformations? We have a vertical compression by a factor of a half because there's a number on the outside that's a fraction. There's a negative sign inside my bracket that is a horizontal reflection along the y-axis. Then we have a horizontal translation 4 units to the right, and we have a vertical translation 2 units down. This. Luckily, we have the same numbers as before for our original function, so I'm going to copy what I had above. It was -6, -3, -1, and 2. Then I have -2, 3, 0, and 2. As I said before, the most important part of this is going to be figuring out our mapping coordinates. So we're going to look at this equation here, the one we've factored already. The things that affect your x values are this stuff inside of the bracket. So we have a negative, and then we have a -4. What that's going to look like is it's going to be -x plus 4. And then what affects our y values? It's this half and this -2. So it would just be a half y minus 2. Okay, we're going to do our math and figure out what all the numbers are. So -6 plus 4 will be a 10. -3 plus 4 will be 7. This will be 5, and this will be 2. This will be -3. 3 times a half is 1.5. 1.5 minus 2 is just -0.5. Because, yeah. And this will be, did I make a mistake? You're okay? And then this will be -1. So just doing a lot of the fraction work in my head, but you can always just get another sheet of paper and then do it there. Okay, and then we graph this, we figured out domain and range, and we're done. So we're gonna have 10, -3, 7, -0.5, 5, -2, and 2, -1. And this graph is y is equal to f of x. This graph is now, when you're labeling it, it doesn't matter what you use. You can use the original or the factored. And then also you just want to see if it makes sense. So has our graph moved 4 units to the right? It seems like it has. Has it moved down 2 units? Yes, it has. Vertical compression, does it look like it's squished this way? Yeah. And horizontal reflection, it's hard to tell with this graph because it's kind of like a squiggly line, but it has reflected. Um, and then for the domain, it goes from 2 all the way to 10. So we're going to have the set of all x values between 2 and 10, and x includes all real values. And then for the range, we're going to have numbers from -3 to -0.5. So the set of all y values such that y is between -3 is the smaller number and -0.5 is the larger number, y includes all real values. Okay, so we're trying this question. I'm going to factor it first. If you're wondering which points to pick, just pick the ones that seem the most obvious. I'm going to pick a random half one here, and this point, and then this point. I really don't like this grid at all. Yeah. Definitely not this. From -4 to 3, so okay, so I've given you a question for the next one that you might not like, but before we do anything, let's practice factoring what's underneath the square root sign. So I'm just going to go over to the side over here. I have -0.5 x plus 2. So I'm just going to isolate that part, ignore everything else. How exactly do you factor something like this? Remember, our end goal is we want our x to be by itself with another number inside the rounded bracket. So in this case, we need to get rid of that -0.5. We're going to factor out -0.5. Think back to like grade 10 factoring. We were learning how to factor a greatest common factor. -0.5 times x will give me -0.5 x, but -0.5 times what number is going to give us +2? Another way to think about that is half of what number results in a 2? 4. And then to figure out the signs, this has to be a -4. And to ease any of your concerns, I will never give you factoring questions any harder than this. So The hardest types of questions will be fractions like this. That's it. Nothing else trickier than that. Okay, and then if you were to expand this again, you'd get -1/2 plus 2, and then that's it. So knowing this, I'm going to rewrite my equation. It's going to be y is equal to negative a big square root sign with -1/2 bracket x minus 4, and then a plus 4 on the outside. And what is the purpose of this? Well, we always want our x to be by itself in the rounded brackets because that's what tells us our horizontal transformation. Oh yeah, no, it's out of the square root sign. Yes, I know it looks a little tricky, but this positive, oh, I'm using block. That +4 is not underneath the square root sign, so you can't add the numbers together. Good question. All right, before we do anything else, let's just state the transformations. And let's just use some of our short forms that we know. We have, what do we have? So there's a negative sign on the outside, so that is a vertical reflection along the x-axis. We have a negative sign on the inside, that is a horizontal reflection along the y-axis. What does the half inside the bracket, inside the square root sign mean? Sarah? Yep, horizontal stretch, because you're going to consider the half to be a 2 when you're figuring that out. Then we have a -4. That means it's a horizontal translation, and we are going to be moving 4 units to the right. And then that +4 on the very outside tells me we have a vertical translation 4 units up. So I'm cheating. Obviously, you guys should write the full words on an assessment. Sarah? Okay, so our original function, our parent function, and you know what, we'll just graph it so that we have a little bit more practice. It's y is equal to root x. So I'm going to have x and y here, 0, 0, 1, 1, 4, 2, and 9, 3. I will be pretty sad if you guys get the parent functions wrong because we've done them so much. So the transformations are new, but the parent functions, I really, really hope you guys have practiced them and get them right. And I'm using y because the original question didn't have it in function notation, but you could use f of x is equal to root x or y is equal to root x. Okay, so for the transform function, which I guess I could rewrite the equation here. You know what? Why? It's too much work. Let's figure out the mapping coordinates. So this is what affects our x value. Does anyone want to guess what the mapping coordinates would be for the x value? Marzu, go ahead. You're right about the 2 and the x and the +4. You're missing one thing. Thank you. -2x plus 4. Good. And what about the y? Anyone want to tell me what the y would be? Sarah? -y plus 4. Good. How did we get that? Well, we have a negative sign here. We multiply that to our y, and then we have a +4 here. We just add that to our y at the end. And then for the x, you just look at inside of the square root sign. All right, let's do all of the calculations and figure out our new points. And you're going to notice we have a number that goes out of our graph, and we just can't graph that one. And you could try to kind of estimate where it would be, but And when you're done, just figure out the domain and range. So it's every x value less than 4 and every y value that is also less than 4. So just like before, for question number 5, I see I have 2x plus 1 inside of the bracket. I'm just going to go over here so we can practice factoring that. If you have 2x plus 1, and I'm asking you to get the x all by itself, I know I have to factor out the number 2. So we're going to have x plus. Now you have to think. 2 times what number is going to result in a 1? 0? Yeah, it's going to be a half. There is another way to do this. If you couldn't get that right away, what you could do is, let's say you just call it an A. You're basically saying 2 times A has to give you the number 1. That means A has to be a half. So if you can't guess it, or like if it isn't logical, you could sort of just go to the side and do a little bit of equation work, and you end up getting that. Okay, so when we come back here for our factored question, actually I'm going to write it here. It's going to be y is equal to a half absolute value sign 2 bracket x plus a half, close bracket, close the absolute value sign. Okay, let's also draw our parent function. Okay, I'm going to label this y is equal to, again, if you're wondering why am I not using function notation, I'm kind of just following along whatever the question has said. If it had f of x, I would use f of x. If it has y, you can use y. Is it wrong to use y or f of x? No, it doesn't really matter. Use whatever you want. So I use green, orange, and blue, and let's use red and yellow. Yeah, sure. Okay. What would the mapping coordinates of this be? Let's do that part together, and then you guys can go ahead and do your own thing. What do you think the mapping coordinates are for the x? So everything in here. The 2 has to be flipped over, and the positive half has to become a negative half. Marzu? A half x minus a half is correct. And then for the y, really, there's just this number over here, which would just be multiplied to your y, and that would be a half y. If you don't like fractions, this is going to be really torturous for you. Actually, maybe not. Yes. The mapping stuff? Sure. Okay. So do you see how I'll just write it in here again, the equation, it froze. All right. So when I'm graphing this, it's going to be -1.5 comma 1, -1, comma a half, and then -1/2, comma 0, and 0, comma a half, and then a half, comma 1. So it's just right in there. That is going to be pretty annoying to graph using this. Well, I'm going to pause this. And this kind of makes sense, right? Because it says that there is oh, by the way, we didn't list our transformations. So if we were to list our transformations, the half in the front tells me there is a vertical compression. That means the graph is compressing like this. And then the 2 inside tells me there is a horizontal compression. So it's kind of squishing in like this. And then we have 1 horizontal translation, just half a unit to the left. So very, very tiny switch, half unit to the left. The domain for this, we're in luck because the absolute value domain is always fun. You can't read that. You can't see that. Hold on. Maybe I'll use that. So the set of all x values such that x includes all real values. And for the range, it's just going to be all the numbers greater than 0. All right, last example. You guys are going to get about 20 minutes to start work. For the rational function, you guys, we try not to make it too tricky because there are already asymptotes and things like that to make it tricky already. So I like to think that the hardest types of examples you'll see are the ones that we have here. Okay, so let's break this down. There will be no factoring for a question like this. You just have to remember that this number and this number here will affect your y value, and the number in the denominator will affect your x value. Okay, so first let's begin by just writing down the points for our rational function. We don't have to graph the parent function though. So y is equal to 1 over x. And I don't think I actually gave you enough spots to include the halves. So maybe we'll just stick to these ones, which is fine. And we don't need to factor anything. The equation is just as it appears. So the only transformation that actually, let's list our transformations while we're here. We have the 4 represents a vertical stretch by a factor of 4. X minus 2 tells me there is a horizontal translation 2 units to the right. And that positive 1 tells me there is a vertical translation 1 unit up. Okay, so the 4 is the vertical stretch, x minus 2 is a horizontal translation, and the plus 1 is a vertical translation. I had shown you guys a little bit of a trick, which I will write down over here. So when we have an equation like y is equal to 4, x minus 2 plus 1, the quick and easy way to figure out our asymptotes is this number here tells me that I have a horizontal asymptote at y is equal to 1. And this number here tells me I have a vertical asymptote at x is equal to 2. And the reason why is, remember, the only thing that affects the asymptotes are when the graph moves side to side or up and down. So this entire graph is moving up 1. That means our horizontal asymptote is going to move up 1 to y is equal to 1. And this graph is moving 2 units to the right, which means our vertical asymptote is also going to move 2 units to the right. And then in terms of the graphic mapping coordinates, it's just going to be x plus 2 and 4y plus 1. Okay? Exactly. It moves when there's a vertical translation or a horizontal translation. Yeah. Okay, so I'm going to draw in at x is equal to 2. And I guess I'll just write it up here. We have a vertical asymptote at x is equal to positive 2. And then at y is equal to 1. So 0, comma, -1, 1, comma, -3, and then 3, comma, 5, 4, comma, 3. That's what the graph looks like. We're going to label it y is equal to 4x minus 2 plus 1. You can clearly see, you guys, your graph has moved over 2 units to the right, and it's moved over 1 unit. And vertical stretch just means it's going to be stretched out like that. We'll finish off this question with the domain and range. For the domain, the only domain is x cannot equal to 2, and the range will be y cannot equal to 1. So we're going to say the set of all x values such that x can never equal to 2, and x includes all real values. And the range is the set of all y values such that it's basically whatever the asymptote is, that is what the number cannot equal to in the domain and range.